Alright, this is lesson 3.6, modeling direct variation. And actually we've already done direct variation when we did our MEP review, and we were looking at the DJ problem, I think it was. We looked at Bash and Benny, and I'm pretty sure we did the DJ problem in here. And he charged $60 an hour. That was direct variation, where we just had the equation y equaled 60h for 60 hours. Indirect variation, the equation is y equals ax, where a cannot equal 0, because if it did, we'd end up with just y equals 0, and that would end up just giving us the x-axis. The non-zero number a is called the constant of variation, and y is said to vary directly with x. So if you have this example, y equals 5x, this is an example of direct variation. Basically, it is slope-intercept form, but the y-intercept is 0. So they're not going to give it to you in this form. They're going to make it a different form and just say y equals ax, but a, that constant of variation, is the slope. So that is the slope. Oh, come on. There we go. That's the slope. The equation y equals x plus 5 is not an example of direct variation because the y-intercept isn't 0. It's 5. Alright, so let's look at this. To tell whether or not it's direct variation, the first thing we need to do is put these in the form where we solve for y. And we have to see, well, does it end up being y equals ax? Basically ax plus 0. So the first thing I'm going to do is I'm going to add x to both sides here. And when I do that, I get y equals x plus 1. Well, right there, my y-intercept's not 1, so the answer is no. Second equation, I'll subtract 2x, so minus 2x. I could put plus 0, but I don't need to. This does follow the rule, and it says if so, identify the constant of variation. So my answer here is yes, and my a is my slope, so it's negative 2. Let's try this one here. I will subtract my 4x, so I get negative 5y equals negative 4x. I have to keep going and divide by my negative 5. So y equals positive 4/5 x. The y-intercept here is 0, so the answer is yes, and the a is 4/5. So you'll be asked to do some problems like that. Next, it says, notice that in direct variation, I've already gone over this with you, the y-intercept is just basically 0. So when they're asking you to graph this, we'd graph it still like we would in slope-intercept form, but now instead of starting at a different y-intercept, our y-intercept is going to end up being 0. So we start at the origin. So let me go ahead and fashion an xy axis for us. So I'm going to start at 0. My slope, which is my a, is 2/3. So I'll rise up 2, 1, 2, and I'll run over 3. 1, 2, 3. Whoops. 3. Come on, 3. And I'll put my point, and then I just draw my line. Alright, next this is the graph of a direct variation is shown, and first they want us to come up with the equation. Well, I can come up with the equation by doing my rise over my run, but I also want you to notice that if we have y equals ax, if I want that a value, I can solve for it by dividing by the x. So this is kind of cool. So y divided by x will give you your a value. That way, if they don't give you a graph to look at and they just give you a point, which could happen, we can look at the point, negative 1, 2. And I know that my a is y. Over x. So my a value is negative 2. So my equation is just y equals negative 2x. So again, I took these points, this coordinate right here, to solve for my a because my a is y over x, and then I just plugged them in, y over x, and that gave me the a value. So here's my actual equation. Now it says find the value of y when x is 30. All right, we just plug it in. So find the value of y when x is 30. Negative 2 times 30. So y would equal negative 60. It's varying directly. I don't have to add or subtract anything onto it. Okay, here are the properties. They're just showing you that yes, it always goes to the origin, and yes, the slope is the a value, which I already showed you. And here they're just showing you, oh, if a is positive, you're going to have a positive slope, a positive line. If a is negative, it'll be negative. All right, here comes the best part of this, is your story problem. We've got basement waterproofing. One way to keep moisture out of your basement is to paint the walls with a waterproof paint. The number of gallons, G, is going to vary directly with the area of the basement. So my gallons is going to be like my y. So it's gallons is going to vary directly with the area. So this is sort of like my x. Well, it is. This is my x. This is my y. I have to figure out this 100 though. You don't just plop in the 100, or I have to figure out the a. You don't just plop in the 100. I know that a is y over x. And if I look at this, I can get a point from here. I have 1 gallon, which is my y, and my area is 100 square feet, so there's my x. So my a value is 1 over 100, and it's just easier for us to write that as a decimal, so 1/100th. So my equation is gallons equals 1/100th times the area. So there's part A. So I had to figure out my constant of variation first. Part B, how many gallons do you need to cover 350 square feet? Well, I'm going to put that in. Excuse me, sorry. I'm going to put that in for the area. So if I take 530 times 1/100th, I'm going to need 5 3/10 gallons. In part C, how many square feet does 8.5 gallons cover? So now 8.5 is the gallons, equals 1/100th times the area. So I'll divide by 100th, and 8.5 divided by 100th is 850. And this is in square feet. Okay, if you want to get started with your assignment tonight, it is right here, page 195 to 197. It's 1, 2 to 22 even, 23 to 27, 30 to 36 even, and 40 to 43. Whoops. There we go. And I will see you tomorrow.